This is the submission of Trackify, which is a team from Institute of Engineering and Management, on the problem statement 1382 from Government of Himachal Pradesh, real-time vehicle tracking system. We have tried to create a highly scalable low-cost system which aims to track buses in real time. We have tried to keep the costs as low as possible and make our entire system decentralized, so that we don't have to rely too much on official bus operators. There's mainly two sources of data for our particular system, and we use these data sources, put them through ML models that we have trained and continue to train on a real-time basis in order to provide predictions on when the closest bus which the user has searched for is available and where is it located. So our first important data source is the crowdsourcing data source. Various different people will be using our app. They will basically input in the particular bus that they are looking for, and at the same time other people who are using our app will be traveling on the bus, and they will input in which bus they're already traveling, the bus number. All of these data sources which will pass into a Kafka cluster. We are using a Kafka cluster because there might be at a production scale there might be around 1000, 2000, something like those data points. In order to stream those data points to our different subscribers efficiently, we are using a Kafka cluster over here. The subscribers in this case of the crowdsourcing data are two AI models. One AI model, its job is to basically take in the its job is to basically predict for a given time and location of a bus at a future location, what time will it take to reach that particular future location. And for the second model, its job is basically for a given time and place at a future given time where the particular bus will be. This is the job of the two models. We use the data that we are getting from this crowdsourcing to train our two models on a real-time basis. At the same time, we store it into a database. This is the crowdsourcing database. The second data source that we have is the camera that we have set up. These cameras are basically set up at different intersection locations, bus intersections as well as bus terminals, basically places where there is a high frequency of us capturing the image of a bus. These particular image feed, or the video feed rather, is sent to an edge server. The edge server performs pre-processing. This edge server, by the way, is on-site. We maintain an on-site edge server in order to reduce the latency. Now what the edge server is doing is that it's pre-processing the data. We take the particular data that we have. We first perform image segmentation to find the particular, if there's a bus in it, we perform image segmentation to find that bus, and an OCR, optical character recognition, in order to detect what is written on the license plate and what is written on the bus route number. Then the particular bus route number, the time when we took that image, as well as the location, all of that is stored into this database. This is the camera image database. Now when a particular person is querying our system for the closest bus that is available to him and at what time it will come, we first take that particular query we pass it into these two databases. When we pass it into these two databases, they provide us with the, in case of the crowdsourcing database, we basically perform clustering first. For the given bus number, we perform clustering. We find the closest bus to the user. This is the clustering performed with the KNN model, which has been previously pre-trained by us. Now we get the data of the closest bus location from this. Over here, we again do the same thing. We find the we take the bus number, and we find all of the instances where the bus was viewed, where the bus was found by camera systems. We take that particular data that we have and put it into our we put it into a location AI. So what it does is that we have from this camera system, we have the date and time, not the date and time, the location and time where the bus was last seen. We put it into this at a particular given time. As the current time when the user has queried us, we find out the location of the bus. Now we compare the result that of the closest bus that we are getting from this AI model, as well as after clustering from the crowdsourcing database. We find the mean of these two. We find the mean of these two. We find the mean of these two particular values, and if there's a huge amount of difference between these, we mainly will prefer the crowdsourcing database because it's more real time as compared to the camera images values. Next, we will try to find the expected time of arrival for the bus. For this, we will go to the second AI. We will put the particular we'll input in the current location as well as the current time, and for a future location, that is the location of the particular user, we find the time that it will take and provide an approximate expected time of arrival for the user. Now, in order to reduce the latency, because we need to perform this entire operation in real time, we want to reduce the latency as much as possible. First of all, we have used master-slave based configuration in our databases. This allows us to have very high read and write speeds, as well as a caching system, in our databases. We are also using load balancers wherever we can in order to further have multiple instances as shown in the predictive algorithm. This allows us to serve multiple different requests that are coming from various different users. We are also processing all of our camera images, the video feed from the cameras on an edge server, an on-site edge server. This further allows us to reduce our latency, and more or less these are the particular steps that we are taking, and we can further improve this particular architecture to further reduce the latency. We have used various different tech stack for our particular project. We are using Amazon EC2 based solutions in order to host our entire systems. We are using HTML, CSS and JavaScript, as well as JavaScript modules which may be required in order to set up our front end, as well as some of our backend functionalities as and where it may be required. We are using Django mainly for our backend because it provides us with a large number of pre-configured modules such as authentication and such other modules. This will allow us to create our application very quickly. Google Maps API will be required by us in order to get access to the person's location and display that on the front-end mobile devices. We will be utilizing scikit-learn and TensorFlow in order to create our ML models which will be required for the predictions, and we are utilizing MySQL as our database management system of choice, because it allows us to create this master slave configurations. It also comes with inbuilt caching systems, as well as it allows us to write complex queries so that we can reduce our query times, query latency, as opposed to NoSQL, which might take comparatively more query latency. Another useful thing about our approach is that we also study the license of the particular bus. We can use the license number that we guessed from the bus in order to find various details such as the emission compliance, as well as the fuel that is used by the bus. Certain other things that we hope to add into our system include a smart fare payment system, such that bus operators are directly able of getting the fare that they need from our system itself. And we also want to provide bus operators new routes to operate on based upon user interaction. Some of our use cases, we believe that how it can particularly help is it can alleviate people's anxiety. It can provide a solution to the huge problem that people face about finding the particular bus they want to board and which time it may arrive. It can help to reduce road congestion by encouraging people to use bus and reduce pollution as well. It makes traveling by a bus safe and easier by basically providing more transparency on when buses are available, and just reducing overall pressure on the person to take it upon himself to find when the bus will arrive and when it will arrive. We also hope that bus operators can increase their revenue by utilizing our platform and find different routes which might require more traffic based upon user interaction with our app. These are some of the dependencies. Proper functioning of ML models and algorithms is definitely required. We hope to experiment and improve the accuracy of our ML models as much as possible, so that we can provide the most accurate results to our users. We are also dependent on bus operational infrastructure to function smoothly. Our services depend on some passengers sharing their location with us. With no passengers sharing their location, the entire functionality of the crowdsourcing mechanism might not work. However, it can be made up for by the camera functionality, because it too can be used to predict the location of buses. But the crowdsourcing functionality, if it's up and running and is used by many different people, then it's a far more reliable source of data for us. Our services depend on reliable and good internet to be present, as lack of good internet connections prevents our users from using our system. And we also depend on the local positioning system for location services, and are looking into integrating the IRNSS system, which is indigenous. This is the team member details. Our team leader is Snehal Ghosh. Our team member 1 is Devan Ghosh, team member 2 Abhirup Sarkar, team member 3 Ankur Debnath, team member 4 Shubham Shahu, team member 5 Devashmita Datta. Our 2 mentors are Tuhima Bhaumik and Piyali Datta. Thank you.